All right, so on with surfaces and displays, images and graphics in Pygame. A surface. So what is this thing called a surface? Well, the surface is Pygame's internal representation of a graphical interface. Okay, but what does that mean? Well, a graphical interface is something that we might look at like a screen that displays images or animations. And surfaces are Pygame's internal representation of these interfaces. So if you think back to when we learned about ranges, we said that they were like Python's internal representation of a sequence of numbers. It's not really something that a user creates and then manipulates like a list. It's really just created by the computer to sort of iterate through numbers in a for loop or something like that. So surfaces are kind of similar. They're an internal representation of a graphical interface that is not actually displayed to a user, but just used by Pygame for managing information. Now, surfaces are also objects in the object-oriented programming sense. You learned a little about object-oriented programming in Snap when we talked about sprites. If you read through the slides about OOP or attended one of the extra Python sessions, you'll understand more about what objects in Python are. If not, don't worry too much about it, but surfaces are technically objects. They're not displayed to users unless we ask Pygame to display one. So again, they're just internal representations of these interfaces, but we can tell Pygame to show one of them to a user, and we'll talk about how to do that a little later. And a single game can have an unlimited number of surfaces. So you can only really have one screen, one window where you display graphics, but you can have an unlimited number of surface objects in your implementation. And we'll see why having multiple surfaces can be useful when we do some demos later. And finally, we can do a lot of different things with surfaces. We can draw shapes, we can load image files, and you can do other things that we won't talk about in these videos as well. And there's a link to the documentation. Okay, so a surface is this internal representation, but how is a surface represented in Pygame? Well, a surface is represented as a grid of squares. Just like in Homework 3, you had a board. In the Tic-Tac-Toe Lab, you had a board. In a lot of your midterm projects, you had a board that was this list of lists. In Pygame, a surface is a grid of squares, and each square is called a pixel. So each pixel has an address that's given by its Cartesian XY coordinates. So you can say pixel 00 or pixel 100. And that'll give you a particular spot on this surface grid. And so if we look down here, we can see an image of this. Here's an X and a Y, and here's an 8x8 grid. The surfaces you work with will probably be a lot bigger, like 1,000 by 1,000 or something like that. But here's a small example. Something important to note. First, of course, it's zero indexed like most things in Python, but also the coordinate 00 is in the upper left corner, not the when that disappears, not the lower left corner like we might expect in a coordinate plane and like we've seen in math class. It's in the upper left. So the X from left to right increases from 0 to whatever, which makes sense, but Y is a little non-intuitive. It starts at 0 at the top and then goes down, getting larger. So remember this, or you could get messed up when you're trying to place things on a surface. All right, so that's what surfaces are. What can we do with them? First thing we can do is load an image file onto a surface. That might be something useful if you want to display an image. So you use this command, or this method, pygame.image.load file name. And again, as we see this and other examples of methods throughout these slides, keep your level of understanding above the abstraction barrier. Like, why is it pygame.image? Why is it not just .load? I don't know. Doesn't matter. That's how Pygame's implemented. All we need to know is that this is the function that loads a file onto a surface. So, more specifically, the input is a string of the image file's name as it's stored on your computer. So if on your computer the image is called alonzo.png, then you would type alonzo.png in quotes, and that would be the string file name. You have to include the dot whatever, so .jpeg, .png, etc. And the output is a surface, a Pygame surface, containing the image. So we talked about a Pygame surface being this grid of pixels, and basically what this method does is it takes the image and overlays it onto a surface. So now each pixel, instead of just sort of being black or having no color, it has a particular color that corresponds to whatever the color of your image is at that spot. So it loads an image onto a surface. And now you can work with the image. However, there is a headache alert that you should be aware of. Make sure that when you call this function, the image file that you're trying to load is in the same directory as your Python code file. Now, it's not impossible to load images if this is not the case, but you'll have to figure out how to use pathing, and that can be annoying and cause a lot of headaches, and it's a lot easier if you just make sure the file is in the correct directory. I'll show you a quick demo of what exactly I mean. If we go here to this directory on my computer, here's this folder called Python code, and you can see some images of a dog and a squirrel that we'll use later, and you can also see some Python files that we'll look at later. And all of this is in the same folder, and so I can just write load dog.png or something. If this dog was in some other folder way over here, I could still access it, but I'd have to use a path, and that can be annoying, and just don't do that. This project, you'll have few enough Python files and image files to where you can all keep them in the same folder, and that will keep your life a lot simpler. All right. Oh. Okay. So that's how you load an image onto a surface. But something else you might want to do with a surface is not just load some image file. You might have an existing surface, and you're like, I want to modify a little. I want to copy something from somewhere else onto it. And we can do this with blitting. So sometimes you might want to copy the contents of one surface onto another. You have surface A and you have surface B, and you're like, wow, I wish surface A was on surface B. And Python allows you to do that with something called a blit. Now, something you should note about blits is that they are methods. Again, if you haven't looked at the slides or you didn't attend the review session about OOP and Python, don't worry too much about what a method is. But this just means that you have to use dot notation to call blit. It's sort of like the list.append function. You can't just in Python write append. You have to have a list and then write dot append, and it'll append to the list in front of the dot. It's the same thing for blit. You have to have a surface, and then you write surface.blit, and you pass in the arguments. If you just write blit, you'll get error messages, and that's because it's not a function, it's technically a method. Okay, so here are the details. You call, again, surface1.blit, and then the arguments to the function are surface2 and a chord tuple. What does that mean? Well, going through these more detail, surface2 is a Pygame surface. This is the surface that you want to copy from. And chord tuple is a tuple of the xy coordinates where the upper left corner of surface 2 will be copied on surface 1. Take a minute and try to digest what that sentence is saying. So it's a tuple. It's a tuple that has exactly 2 items. The first one is an x coordinate and the second one's a y coordinate. And it's the coordinates where you want, if we're copying from A to B, it's where you want the contents of surface A to appear on surface B. Okay, that makes sense. But it's not a whole area, it's just one particular coordinate. So maybe we could have said it was the midpoint of where we want it to appear, but the way Pygame does it is it's the upper left corner of where that surface is going to appear. So if we go back here, we look at this grid, let's say we want, this is surface B and we want to copy surface A and we want its contents to appear here in this area, and I'm outlining with my mouse. Well, the coordinate I would pass into the blit function would be 1, 1. And then this would be the upper left corner of the surface, and then it would go down through this area. So that's just how Pygame works. It deals with the upper left corner of surfaces in blits and in other functions we'll see later. And the behavior, as I've been describing, is it copies surface 2 onto surface 1 at the specified location. That's a blit. You'll probably use these quite a lot. Okay, so that's surfaces. Those are Pygame's internal representations of interfaces, but that's not really good if users can't see them. So how can we make users actually view our surfaces? Well, we do that with what's called a display. It's also sometimes called a screen. I will call it a display in the rest of these slides. And a display is just a special type of surface. Still a surface. You can still load images onto it. You can still blit it. But it's a special surface that's displayed to users. So this is the one surface that users can actually see. You know, the Pygame window opens and you look at the contents of this surface. All the other surfaces are just inside Pygame doing their thing, and we can't look at them. So to initialize a display, to tell Pygame, hey, I want this surface to be the one that users see, you call pygame.display.setMode, and the argument is a dimension tuple. Okay, well, what's a dimension tuple? That's a tuple containing the width and height that you'd like to set for the display window. So Pygame does not just automatically set the display window to be your full screen. It's a window, and you can choose what size you want the window to be. I would just recommend messing around with this and seeing which dimensions you like best. You want a big window, a small window, depends on your game. The particular dimensions also depend on your machine. I've noticed that 1,500 for the width and 500 for the height works on my machine. You can start with that maybe, and if it gives you a weird dimensionality, just change things until you find something you like. The output of this function is the display surface that is created. Again, the display is just a surface. And the behavior is that it opens the display window with the desired dimensions that you input. Now, take a second and think about this slide. Look at it. There's something a little bit weird about how this function works. So normally, a function in Python has either an input and an output, takes in some input and produces some output, and that would be like a reporter in Snap. That's one thing we've seen a lot. Or it has an input, and then it doesn't produce an output, but it does something. So it's like a command in Snap. It takes in an input and, I don't know, updates some display or changes something, but it doesn't output anything. The append function that you've been using to update lists is an example of that. So those are the two normal cases, and you should be careful when you're looking at these slides and looking at the methods. Notice which ones have an input and output, and which ones just have an input and a behavior. There's no easy way to distinguish reporters and commands in Python. You just have to know what each function does. But this function's a little weird. It has an input and an output and a behavior. So it both outputs something and it has a side effect. So that's sort of weird. Maybe you're like, this is not a real function, a pure function. Why did Pygame authors do this? I don't know, but they did. So it's just important to understand how it works. The behavior of this is that it opens the display window, so now the user can view something, but it also outputs the the particular surface that's being displayed. As I said, a display is just a subtype, a special type of surface, and that's going to be output by this function. So you'll always want to save the output of this function in a variable, because if you don't save it, you can't update it later. The user's going to have this display, and you're going to try to put other things on the display and change it, and if you don't save that particular surface as a variable, it's going to be lost when this function runs, and you won't be able to update it. So that's an important note here, and a weird sort of anomalous thing about this display function. All right, so now on to colors. So by default, all surfaces, including the display, have a black background in Pygame. So all of those little pixels, those squares, are just set to black. And again, note here that surfaces have colors, not just the display. The display is the only one that the user can see, but all surfaces have pixels, and all those pixels are set to colors, and by default, they're just black. But you can change this. You can change the colors that users see. One way you can do this is use the surface.fill method. So the input here is a 3-element tuple containing the red, green, blue value of the desired color. And surface is the particular surface you want to update. And the behavior is change the background color of surface to the color corresponding to the given RGB or red, green, blue value. Okay, but wait, you're probably thinking, what is a red, green, blue value? Well, how does that work? Well, a red, green, blue value is what you can see on the chart on the right of this screen. In Pygame and in a lot of applications for computer science, colors are represented as combinations of red, green, and blue. So some sort of mixing of red, green, and blue in the pixels. And the amount of each color is represented as an integer. So this weird thing over here, 0, 255, 255, well, that's 0 red, 255 green, 255 blue, and that makes aqua. Who knew? So how do you figure out which integers to use? Is there like some secret code? No, you look at the table or you look online. Yeah. So updating the display window. How do we update this display? Well, first, a note. As I said, the display is just another surface. So we ran that, python.display.setMode function, and that initialized the display, and it output a surface, and we saved that surface into a variable. And so because we saved that surface object in a variable, we can update it later, we can fill it, we can blit it, we can load images onto it, we can do whatever we want. But a very important note, just because you change the surface does not mean that the display window also changes. In fact, it doesn't. You can save that surface that's created in a variable and manipulate that all you want, but users will never see those changes unless you specifically tell Pygame, hey, I've changed the surface that's the display, now show that to users. Okay, so you need to explicitly tell Pygame to do this, and you do this with the pygame.display.flip function. This doesn't take any inputs, it doesn't produce any outputs, all it does is it updates the display window with the contents of the surface. So first we run set mode, we save the output in a variable like screen, and then we blitz something to the screen and we create this cool thing that we want users to see, and then we run pygame.display.flip, and now the window actually shows the surface that we created. So it's important to note the surface and the display window are disjoint in Pygame, and you need to tell Pygame to link or to update the window based on how you've changed the surface. Okay, so that's a lot of talking. Let's do a quick demo to show what we've learned. So here I have a Python file, just called it demo. The first thing we want to do is set up our environment. So set up the environment. So I'll type the things that I should always type when I want to use Pygame. Import Pygame and pygame.init. All right. And then at the bottom, again, I said we should always have something to exit Pygame properly. So I'll write pygame.quit. Okay. Now, what do I put in the middle? Well, let's remember our task. We want to create a game that models the relations between dogs and squirrels. If I want to do this, first I need an image of a dog and a squirrel, and I need to show it to people. And we've learned enough Pygame now to where we can do that. So let's do it. So here we're going to draw the initial image. Images. So first, I want to create a surface that has the dog image. So I'm going to say dog surface equals pygame.image.load dog.png. And this is just going to create a surface, assign it to the variable dog surface, and load that image onto it. So now I have a surface that represents the dog. That's great. Hey, let's do the same thing with the squirrel. We'll do squirrel surface equals pygame.image.load squirrel.jpg. Hooray, 2 surfaces, 2 images. But users can't see these yet, so let's fix that. So I'm going to create a screen, create a display by calling this setMode function, and again I'm going to save it in a variable called screen. So we're going to run pygame.display.setMode, And as I said, I like the dimensions 1500 because I've experimented already, so I'll use those. Okay, so now we have this display and it's shown to users, but note that I never put the surfaces with images on the display. So if I just ran this code right now, it would just be a black window. That's all the user would see, and that's not really useful, so let's see how we can copy these. What I'm going to do first is create this list called dog position, and it's going to be 200, 200, and that's going to be the position where I want the dog image to appear on my display. Remember, when we blit, we have to tell Python, hey, I want you to copy this image into a particular location, so I'm saving that location as a list. I don't necessarily need to do this, but when we get to later demos, you'll see why this was useful. For now, you should just understand that I'm saving the position of the XY coordinate in a list. Okay. And then I can call screen.blit and copy this dog image onto it. So I'll do dog surface. So that's the surface that I want to blit. And then the coordinates are dog position item 0 and dog position item 1. And if you're like, Skylar, why did you make this list and then write 0 and 1? You could have just written 200, 200. You're right, but again, you'll see why this was useful in a later demo. Great, now the dog is there. Let's make the squirrel be there. So we'll do squirrel position equals, where did I want? I want it at 750, 200. I experimented to find out that I like these positions, but I do. And then we'll blit this onto the screen. Screen.blit squirrel surface with squirrel position 0 and squirrel position 1. And finally, now I updated the screen, but I haven't release those changes to users. So at the bottom, I need to call pygame.display.flip, and now users will be able to see my beautiful dog and squirrel images. So we're basically done. We use the tools that we learned about, loading images, blitting, creating a display, updating it to display these to users. Now, there's one little extra thing that I need to add. So I'm going to go up here and actually import something else, import Python's time library. And I want to pause so users can view the display. If I just executed this file as it is now, what would happen is all this code would execute, Python would open the display window, then it would update it, and then immediately afterward it would quit. And so users wouldn't be able to look at the dog and squirrel images. It would be there for like a split second, and then, oh, it's closed. And that's not good. So what I'm going to do instead is add in, using Python's time module, time.sleep for time.sleep for 10 seconds. And that's going to basically pause this script for 10 seconds. You don't really need to understand how this works. You actually shouldn't use this in your code. We'll learn a better method for how to pause and close Pygame properly in the next video, but for now we don't know about that, so I'm just going to use this hack to pause it so we can admire our work. So now I save this file, and if I go python demo1.py, assuming it didn't produce an error message, we'll see. We have this display window, and our dog and our squirrel are displayed in it. And it waits for 10 seconds, and then it closes. So hooray, we've displayed a dog and a squirrel. Now you know enough Pygame to where you can do this too.